Hello, my name's Tony Cosentino and I teach math at Harold Washington College. And this video is going to be a tutorial or a summary about exponents that are represented as a fraction. And this will be very helpful for those in the college algebra, pre-calc, and definitely calculus classes. So let's get started. So what do we mean by the idea of an exponent that's represented as a fraction? Well, back in the old arithmetic days, we used this idea of a square root sign, which is actually a radical. And the idea of being able to take square roots of numbers. For example, the square root of 4, this is the idea of what two numbers multiplied together will give you the number 4. And the principal root is the answer would be a positive number, and it would be 2, right? Because 2 times 2 equals 4. But how do we deal with that with regards to the idea of an exponent and represented it as a fraction? And if we talk about the same square root of 4, the first thing you want to think about is that there is an applied number that goes there, and that number is a 2. And that's what we mean by square root. What two numbers multiplied together will give you 4. And you can think about that as writing it as this is the denominator of a fractional exponent. So what I mean by that you could write this as 4 to the 1/2 power. And this type of representation will become very, very useful, like I said, especially when you get into calculus and again, taking derivatives. So if that number is not 2, then you have to write it. For example, if we put the cube root, we would have to write a 3 there. And then if you took the cube root of 8, what number that if you multiply 3 times will give you 8? That would be 2 times 2 times 2. So the idea is now we're going to put this in more of an algebraic representation and how to be able to convert these radicals into a fractional exponent. And like I said, in calculus, you'll find this very, very helpful. And so let's start with a simple one, hopefully. Square root of x cubed. So what do we do in trying to convert that from the radical form, say, into a fractional exponent? Well, remember, it's an implied 2 here. So that'll end up going in the denominator. So you can put the 3 in the numerator and the 2 in the denominator. Let's do another one. Say like you had x to the 5th. And now we do the cube root. So there you would have to put a 3 there. And that means that the 3 is will go into the denominator in our fractional exponent. So when we do that calculation, you would get x 5 divided by 3. Let's make it a little bit more complicated now. And let's talk about a representation that looks like this. So first of all, if you remember, there's another video that talked about how to deal with exponents that go down into the denominator. And this is the idea that we could rewrite it first this way, or it'd be to the minus 2 power. And remember, if the base is 1 over x, To change it to a negative, you flip the base, and so it'd be x over 1 or x to the minus 2 power. And remember, there's an implied 2 here, right? I'm going to write it in red this time. So it would look like this, x to the minus 2 power divided by 2. And here we could do a little bit of arithmetic, right? 2 goes into 2 one time. And so you could write this x to the minus 1 power. And you'll see that when you're in calculus and you want to take derivatives, you'll want to leave it in this form. But if you wanted to write it in the other form where you would have a positive exponent, right? You would put the base on the bottom, and we typically don't write to the 1 power, right? But you could do that like that, and it would be to the 1 power. Okay, let's take a look at one more. I mean, this one might be a little bit more complicated, but say like we did this. And say like we had x squared over y cubed. And say like you were trying to convert this into a fractional exponent. So the first thing that I would do, I was working on this problem, and there's multiple ways to do this, but what I would do is bring all the variables up in the numerator. And that would mean that we'd leave x squared up here, and we would change the sign of the exponent in the denominator so we can bring y up in the numerator. And so that would be y to the minus 3 power. And now, since they're multiplied together, we could distribute the cube root as a fractional exponent, and it would look like this. And so to finish this, you could do a little bit of arithmetic in the exponents, and 2/3 is the simplest form, but you could see you would have y to the minus 1 power. And again, this would be a good representation in calculus, but if you wanted to get rid of the negative exponent, you could bring the y down to the bottom, right, or into the denominator, and you get divided by y. Well, this ends the video on fractional exponents, and hopefully this helps.